Well, good afternoon, good morning, or good evening, depending on where you are in this world, and welcome to today's Devops.com webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. Before we get started with the webinar, we do have a few housekeeping items to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be receiving a link post-event in an email that you can access the webinar on demand. And also, we are taking questions from the audience today. So if you have a question for our presenter at any time during the event, just use your control panel, type in your question in the question box, and we'll take a few minutes near the end of the presentation and go over the audience questions. Okay, with that, I'd like to jump into our webinar, How to Build an Intelligent Traffic Management to Automate Delivery and Control Costs. Our speaker today is Arnaud Becart, Solutions Engineer at Citrix. Hello, Arnaud. How are you?
Hello, I'm fine, Charlie. Thank you.
Great, great. Well, I'm going to go ahead and just turn it over to you, let you do your presentation.
Yeah, sure. Thank you. So, hi, everyone. So I'm Arnaud Becart from Citrix, and actually historically from Cedexis, for those of you who has been acquired by Citrix 4 months ago. And here I'm going to talk about the ways to build an intelligent traffic management and see how it brings benefits in automation, control costs, and optimize user experience. So before to start with, I'd like to say a few words about traffic management in itself, what it is first. So it's commonly known also as global traffic management, or GTM, which is kind of a known word for the industry. It's usually globally distributed platform, hence the G in the GTM, obviously, and it's a SaaS platform, shared platform, which can easy to scale up or scale down. And the way it works is most of the time it's going to work at the DNS level, which means to translate a domain name like www.example.com and transform that to an IP address or to a CNAME, which is basically to point that to another hostname. It's sometimes also referred as a next generation DNS, and we're going to see why it can be called this way afterward. What it is not is it's not a local load balancer. It's not a local GSLB, a global server load balancing, as it's sometimes called, because main difference here is that GSLB are usually proxying the traffic, whether it's DNS or HTTP based, and is privately owned and managed by the customer in these private data centers or in the cloud, but it's usually not a global platform. So the two are very complementary and works really well together. So if we take this example, www.example.com, and we want to send that to the right server, well, first we're going to ask to the GTM, where is the best data center, where is the best region, cloud region that I need to send the traffic to. And then the local GSLB will do the local load balancing based on the local KPIs to select the best server inside this data center or inside this cloud region. So the two are very complementary, working together, and works with very basic use case, I would say, but very functional as well, as long as you have at least two endpoints, like two data centers or two cloud regions. Some use case that we quite often see are round robin, where you have duplication of audio content or sessions across data centers, and you just want basically to spread the load across these data centers. Geo rules, which means, for instance, you're in the US and you want to go to the US-based data centers, or if in Europe, you're going to go to the European one. Most of the time, it's going to be a mix, actually, of round robin or geo, or mixed with failover rules as well, which means how to remove traffic from a data center if it's not available. So based on some synthetic monitoring, I will remove a data center. So it's kind of basic use case that we see quite a lot. But here in this webinar, we're going to see and discuss how we can make this a bit more intelligent. So what could a traffic management achieve to make it more intelligent? First, well, one of the main important need, I would say, and is to make sure that the application or the service that is delivered to the end user is available, but when you say available, is highly available. Secondly, how it could improve the end user experience. Then we could also use the local data center conditions to know what the conditions like internal error rates, internal load. So basically get some information from what happened inside the data center or inside the cloud instances, and use that as part of the traffic management solution. Then you could also use the internet, because obviously anytime we talk about delivery of web application or web content, it needs to go through the internet. So it would need to do some kind of data. Real user data driven, we're going to see how it can make this very, very close to improving the user experience. Flexible rules, so basically have a very highly programmable load balancing engine. Automated in real time, because obviously this needs to be very fast and respond very fast and make it automation. And last but not the least, this traffic management platform needs to be very available as well, because it should not break any availability, it should not break anything in the user path when it tries to ask and get content from its apps or service. So just to go a bit more in details in these different components and different ways to make this traffic management a bit better, I'm gonna explain here the way we think about delivery. I mean, we at Citrix, which is now Citrix ITM solution, so intelligent traffic management. So first, when here we think about, okay, an end user needs to access to an endpoint, which can be a data center, or it could be a cloud. What would be the best choice to do? So the first question we're going to ask is the service running? So let's take a very simple maybe analogy to understand the way we think about delivery, and think about an example you could have in your daily life. Like, okay, you want to go to a restaurant, you want to order a pizza, for instance, and you say, okay, which restaurant am I going to go? First, obviously, the first question to ask is the restaurant open? So is this service running, and will I be able to get some pizza when I arrive there? So that's basically the idea of service. Is this service running? So to do that, you need to make some proactive testing, or to get some information about, okay, can I reach this place? Can I reach this server? Can I reach this load balancer with some synthetic monitoring? The second thing that you're going to ask is, what about the last mile? Is the last mile healthy, and is it fast to reach these services? The internet is not necessarily like a big blob where you don't really know what it's saying. Well, for most of the people, that would be what it is, but it needs to transfer to multiple ISPs, sometimes goes through CDN infrastructure. So there are many ways to have a service that can be slow between the end user, especially on the last mile perspective, and to reach its services. So if you think about this analogy about how to get my pizza at that restaurant, that would be, okay, what would be the best way to go to that restaurant? And the best way to do that, it would be to get information from actual end users that will go to that place and get this information to take a decision in which way I should go to get to that restaurant, basically. So first now, let's focus on is this service running, so on high availability. So how to make this app very available, so always up. We hear sometimes more and more about always on services. So basically application for which there can't be any outage. And we hear a lot about these 5 nice rules, which basically mean how to reach 99.999% of availability. So if we look at what it makes in terms of number of minutes, or I should say even seconds of downtime, it's pretty amazing, because when you want to reach 5.9, basically that means you are up to only 6 seconds of downtime every week. So when you monitor the availability, it's not just a matter of having an HTTP check every minute to detect some outage, some global outage on a data center, for instance. It's a matter of seconds. So to achieve that, so this is one of the products we've developed to basically monitor a data center endpoint or cloud endpoint, not just every minute, potentially every minute, but very potentially that very higher frequency, like every 30 seconds, every 10 seconds, but potentially every second. It's something that we've developed this way. We provide some reporting on that, but the idea here is that we get this data done, we provide some alerting, but most importantly, we can use this data to switch traffic from a data center. Most of the monitoring tools already today cannot go to that level of frequency. Most of the time it's going to be every minute or sometime every 30 seconds. Some will be able to do, but then there might be some cost associated with the number of data points that you're going to need. So with this high availability scenario, the idea is that in the intelligent traffic management platform, every time we detect an outage from these external locations, we're going to be able to switch traffic, so to remove the traffic from the data center that cannot be reached from the internet side. And in such a scenario, which remains kind of easy to understand, we're going to send all the traffic to data center number 2 in that case. So this is high availability. But now if we're going to talk a bit more about performance and geo, because when you think about performance, usually we say, okay, I want to send my user to somewhere close. So like for example, today I'm in London. If I want to, assume I want to go to a cloud region on AWS, I would prefer maybe to select the region from London. But sometimes another region might actually be a better choice for me, depending on where I am. Because when we think about close in the network point of view, it doesn't necessarily mean close in terms of geography and number of and the distance between me physically and the city where the data center or the cloud regions or even the CDN nodes are present. So in this example of figures, I took some data that we collect and that I will detail a bit later, which we call radar data. I took some, so this is based on real user data that measure the latency between basically end users in London. So all the ISP in London are shared. And so the latency to reach the different AWS regions. So in that case, the London one, US, the Ireland one, and the Frankfurt one. So you see in the middle, the median, which is the 50th percentile, which means that for most of the end users, it's going to be 23 milliseconds from London to reach locally the London AWS region. And it's going to take 34 milliseconds to go to Ireland and 35 milliseconds to go to Frankfurt. So you see, to go to actually Ireland or Frankfurt just doesn't make any difference in some scenarios because, well, put here in kilometer the actual distance, and it can take much more time physically to go to Frankfurt. But from a network point of view, it's going to be as fast as to go to Dublin, and not that different to go to London actually. And if we look at the highest percentile, like the 10%, the 90th percentile, which is the 10% slowest users, you're going to see even sometimes the difference to go to London or to go to Ireland is going to be pretty close in terms of latency, and end user experience could also be kind of similar. And one of the reason and main reason for that is, again, the fact that the internet is really basically interconnected networks between the end users and between your data center or cloud, which you have to go through. So it's usually based on BGP, which is based on the number of hops rather than the actual performance. And in reality, what we are going to see is outage, congestion, and packet loss, which is going to degrade the user experience to go through all of these regions. So I want to go to an endpoint which is close, but I want also to go to an endpoint that will deliver very fast. So again, this last mile connectivity is going to be very, very important to make sure that I get to the closest endpoint, but to the fastest endpoint, I would say, to make sure that I can get most of my requests to a server in less than 100 milliseconds. And here I took the example of close regions, like I took the one in Europe. But if you go like even much further, like in the US, in Asia, the latency here is going to be sometimes five times or 10 times what it is. And it can make the usage of an application really much slower or almost unusable if we have this latency. So there is a matter of close, but also a matter of short and fast latency between end users that needs to be taken into account to select the best endpoint from end users. Other part that we need to focus on is that this the internet is gonna live, I would say, which means, I mean, from time to time, depending on the usage on itself, there are going to be more packet loss, more congestion issue, and there could be a lot of differences in the response time. So this is based on real data, again from London, which I took as an example as well, to reach the different AWS region, and from time to time, from hour to hour or minute to minute, there can be a lot of variation, which would make some region much close from a network point of view, I'd say, than others. Some other measurements based on real data as well is about performance from actual end users to reach the different CDN, so which are platforms that we monitor today. So what I took here is also data from London to reach 5 top CDN, which I took, for which you see they are not going to provide the same level of performance, which will depend on a lot of criteria, but some on the local networks, but also on the point of presence, the peering connectivity that this CDN server have to provide this performance. One more point about availability. So we talked about this server and data center availability. So are we able to reach that server? But another question that we can ask is how to know about the availability from the actual end users to a platform itself. I just took here one example to illustrate that, which was in May, where Russia banned Telegram application and subsequently blocked quite a lot of IP address from Google and AWS. This is something that we saw with our user monitoring, because basically what we saw is some of the AWS IPs being blocked, and so provide a bad availability rates from end users in Russia as well. So now these are what we want, I'd say. Some want to reach somewhere which is close, which is fast, which is available, but how to know that? How do we get this data? So there's something that a lot of websites that you probably browse and use every day for some of them that share in common. And what do they share is a basic script. It's a simple line of JavaScript that is deployed on most of these sites, or it can be on mobile apps. And what this script is going to do is that it's going to trigger proactive measurements on the major platforms, so on major cloud platforms and CDNs and data centers for some of the customers. And this script is going to monitor the availability. Can we reach this platform quickly? And without any error, the response time, so the latency between the end users and this platform, and the throughput. How does it work? It's very easy. It's basically the script is loaded after the page loads. So when you go like on LinkedIn, for instance, and you're gonna open the page. So when the page is fully loaded, the JavaScript tag, which is called the radar tag, is going to trigger automatically and transparently for the end users. And we start collecting data, which means we start to measure the major CDN clouds or data centers. And we're going to collect this data in real time and be able to use that in the traffic management. So based on this data, we're able to collect quite a lot of data because we have, through all of these websites, a community of websites and end users that are participating in monitoring these major clouds and CDN and data centers. We collect today around 14 billion data points per day and from almost 1 billion of end user sessions every day. So it's quite a lot, but it's necessary because there are a lot of problems on the internet. There are a lot of networks, and obviously things needs to be monitored in real time because the outages can happen from 1 minute to another one. So now you get to okay, we've got this data. How can we use this data in real time and make it actionable so that we can use this into the traffic management solution and send the people to the right place? So this is basically what we've developed with originally Cedexis, which is now Citrix ITM. And to make it easy to understand, we can make this analogy about Waze for web apps. So for those who know Waze, it's using obviously real user data from people who drive their cars and want to reach a destination. It's going to collect the time for these actual end users to reach the destination based on different paths and provide the best information to send the people to the right route. Well, basically, ITM is essentially the same from the monitoring of the internet point of view, because we collect this real user data and we use it real time to say to this end user to send that to the best endpoints based on the information that we have. So the way it works, so we collect this data, quite a lot of data. So based from the real end users, when a user goes on the website, it will ask to the ITM engine, which can be DNS or HTTP based, to see where is the best place to send the data. There is a programmed algorithm, so the programmed load balancing rules that is defined to say what is the best criteria, which can be based on location. So is it close? Is it in the same region? Based on availability, based on the high frequency tests we can have, based on the end user performance, and some other criteria that we'll see after. So the final of that is to send the end user to the right place. So it can be send that to the right local cloud regions with the local GSLP that's going to do the internal load balancing after that. So this relies on a shared platform today, which consists of across 120 POPs distributed worldwide in 4 Anycast layers, which gives us some redundancy for performance, but also for a high availability point of view that makes this much less at risk to have multiple providers. We rely ourselves, our own platform, on multiple cloud providers to mitigate risks and give performance. It's a very highly scalable platform. It's quite easy to add capacity when necessary. There are a lot of layers of protection against DDoS attack, against malicious traffic, high volumes of attack that can be blocked by multiple ways. And we also have a dedicated infrastructure in China because that's a region where there are quite a lot of network performance issues that we can solve through this ITM solution. So as I said before, we have 2 ways to do the load balancing rules. First way is DNS based. So pretty easy. It's basically instead of pointing a domain name to an IP address or pointing that to a CNAME from a CDN or from a data center, we point that to Cedexis CNAME and the Cedexis.net CNAME is going to reply with the best choice, which can be a CDN, it can be an IP address, or it can be a cloud region. We have also another way to integrate this load balancing through an HTTP API, which looks like, as you see, basically that's a JSON file we get with an order list of providers, which can be CDNs, clouds, or data centers. It's commonly used for video use case where it's the player or the CMS who is going to trigger this request to know what's the best platform to use and on which platform to get the video content from the best way. This load balancing rules is very highly programmable. It's based on JavaScript language, ECMA5 supported. It's really made to be able to program any custom rules that we want to take into account. So taking into account the performance information we have, the load balancing rules, the geo information, the availability KPIs, and much more. We provide some reports on that. So here is a good illustration about the network performance, so from the actual end user point of view, where we see from some ISP, some availability drop on the CDN, and automatically this traffic management solution is removing any traffic to that CDN so that it doesn't impact the end user experience. And all of that, of course, is automated, so you don't have to care about this issue, which can be a local ISP issue to reach that CDN node, or it could be also a major issue on the CDN configuration itself that will make this traffic unavailable for that end users to that CDN. So now we can ask, okay, is that enough? I mean, taking into account the availability and the real end user performance point of view? Actually, the answer is not, because there are other ways to make that a bit better. So if we go back to this analogy that I took before about how to get to my pizza restaurant, so the quickest way, and if this restaurant is actually open or not, we can ask some other questions like, okay, in that restaurant, am I gonna get my pizza fast or not? Because maybe they are very slow in the kitchen to make the pizza because we have one people for a lot of customers. So that's kind of the question we can ask in the internet and data center world about what the status of my application in my data center. Is it too loaded, maybe? Or is it does it consume too much CPU? Do I have too much error on that one? So this is why we could also get some kind of load feedback on the application and server metrics and use that as part of the ITM, so Intelligent Traffic Management Solution. Another way to make that intelligent is also to take into consideration the cost, because probably, especially true in the CDN world, but as well, if we compare data center and the cloud delivery cost, probably the costs are not going to be the same if it's your own connectivity, your own hosting versus a cloud platform. Sometimes it's going to be cheaper, sometimes it's going to be more expensive. It has a lot of consideration to take into account. But the idea is that why not take that information into account? Going back to this restaurant analogy, okay, maybe pizza restaurant is there are two places which are as fast to go there. They are both open. They all have, let's say, good people in the kitchen that will get the pizza fast. But maybe one is actually twice the price. So I better take that into consideration and go to the one that would maybe cost me less money. So to illustrate this principle, here is an example of delivery where we take into account load of the infrastructure, and the idea is to potentially offload traffic when it's necessary to one endpoint or to another one. So in that example, we can still use, so we've got an example here with two AWS regions with a local netscaler to do the local load balancing. And we've got as well a private data center that can also get the traffic. So the radar monitoring is going to collect the time, the latency, and the availability to reach these different cloud regions based on the real user feedback. So this can be a first way to use the data, but let's assume all of the radar networks show good performance, partly equal across the regions. So what we can do is to retrieve some information coming from the data center and the cloud region itself to achieve that. So for that, we've got multiple ways to get the information. We've got some API connectors to Netscaler instance, for instance. But we've actually developed quite a lot of APIs to the major CDNs and cloud providers. So to Netscaler, I've got a plugin, to Nginx as well. So any custom API we can get to a third-party tool. Could be also APM or network monitoring solution. These are kind of information that we can ingest into the load balancing solution so that we take into account this additional data to switch or to remove traffic away from an overloaded region or an overloaded data center in terms of capacity. Coming back to the cost control, well, as I said before, it applies quite well in CDN world, but I would say more generally in a hybrid scenario, because, well, usually people who move to cloud is for a new application, but sometimes it's hard to know what's going to be the level of traffic of that application. And from some point of view, sometimes people also want to keep control and keep hosting and in a primary data center of this application. So that's why we see more and more this hybrid scenario where traffic is split between a cloud and a data center, or between a CDN and a private cache, a private data center. So here I've got an example for delivery between two CDNs and a private data center with a local caching. So obviously we can have all the network and application performance monitoring as external data that we can use, but we can also take into account the cost of the CDN or the cloud itself. And as I said before, if performance from the external point of view, but also from external monitoring is about the same, why not go for the CDN or the cloud region that will be at the best cost in terms of saving money. This video cost and multi-CDN model applies quite well as well in the field of video because that's kind of heavy volumes that are delivered through most of the time CDN, but also sometime on a private cache. We can also use video data as well as part of the decision, like base the decision to go to one CDN or to go to your own cache server based on the video quality, like on the throughput on the actual chunks that are delivered to the end users, or based on the rebuffering ratio. So this, depending on this type of data, this can also be part of the ITM solution and will bring obviously much more value for a video delivery use case and to basically reduce the rebuffering and provide a better video quality. So before to conclude, if you wanted to make it also again go back to this Waze analogy. So Waze analogy is kind of, okay, this is what ITM, so Cedexis, before it was acquired by Citrix, was. So basically use real user data to reach the best endpoint through the best route. But with how we saw, it can be actually much more than that. And if we have this Waze analogy, that would be as if we were also taking into account like the accidents on the road, like the fact there is a police, and so there will be some slowness at some point. We could take as well the cost to reach these different routes and many other criteria that we can program to switch the traffic intelligently between the different endpoints. So to conclude and to sum up what a Citrix ITM is, basically, first it relies on the platform, so a shared platform, which is globally distributed on multiple networks for high resiliency and high performance, and which can be scaled up very, very easily if traffic grows. It's also monitoring, so many kind of monitoring, so real user monitoring based on the actual point of view from the end users, what's the performance to reach the major cloud and CDN platforms, synthetic monitoring at a high frequency, third-party data as well, so Citrix Netscaler, but also many external tools from which we can get data and use that into the decision making. And it comes obviously with some reporting raw data that we can send also. And the traffic management itself, which can be DNS-based or also HTTP-based for the video use case, which also includes authoritative DNS in order to manage and host your DNS zone and do both the static recall management plus this dynamic load balancing DNS-based rules. This applies obviously at the minimum if you have multiple endpoints. So when you say multiple endpoints, the multi-data center is a good start to reach that, to start with this kind of solution, because you can apply different rules like high availability, most importantly, geo-based rules, and different kind of engines, programmation engines. Hybrid cloud scenario are going to be a good use case as well from a performance perspective, because cloud regions could be closer to the end user, but also from a control about cost and performance. Multi-CDN, which is a good use case for large file downloads and video use case, where you usually put one CDN, but one CDN will not necessarily provide the availability and the performance for all the end users. And I'd say a mix of those, which can be a mix between data center and CDN, or between cloud and a CDN, as we see in different parts. So at the end, what it will bring, this intelligent traffic management, well, it will bring automation, because the idea is that to use real user data or to use third-party data, the idea is that you automate the load balancing rules to make that well, to make that works, I'd say, for the end user's point of view, but to make sure that it's gonna improve over the time. Basically using the monitoring data of your data center, so the high availability checks that we saw, then using the real user data to know, okay, where is the best endpoints to go to from the end user perspective. So like in this example, like a cloud A, B, and C. If for all of these users, these cloud regions looks good, now let's go to what's happening on the inside and see, okay, maybe in that case, cloud A, cloud B are a bit overloaded, have a lot of traffic there or have a lot of errors, and C region might be a best candidate. So if we send now more traffic to this region C and less to A and B, that gives time to this region A and B to self-heal, to get less traffic, to correct some errors, so that in the end it should resume to normal traffic across the different regions if all are globally available. So that's the promises of the Citrix Intelligent Traffic Management, is that basically DevOps team don't need to wake up in the middle of the night and basically fix issues on the platforms, because the idea is to implement ways to automate and avoid any major issues that will impact real end users. So using analytics, different kind of analytics that we saw, and the idea is really to be much more in a proactive way than a reactive way, because use data and remove traffic to avoid big outage or outage that will impact the actual end users. And of course, the idea is not to wake up the DevOps team for an issue that is not a big issue. But once again, the idea is really to make sure the end users are not going to be impacted by automating the different roles. So that concludes this webinar. Thank you everyone for listening and attending to that. And I believe now that we're going to have some time for a few questions if we have. So thank you.
Yes. All right, great. Yes, so now is the question and answer period. So if you have a question for Arnaud, please go ahead and use the control panel, submit your question. We've gotten one in so far, so hopefully we'll get a couple more, but we'll go ahead and start with the first one, which is, so is ITM already available for Citrix customers?
Yeah, okay, well, thanks for the question. So the answer is yes. So we have a couple of comments on that. So Citrix has been existing for 7 years before it got acquired a few months ago. So all the solutions that have been presented here are solutions already used by quite a lot of customers, actually. Some of the reference that we saw initially, like the customers who participate to this radar community, most of them are also using this ITM solution. So yeah, we already have customers on production on all of these products, and this is now going to be open to, I'd say, the Citrix world, which can be Citrix existing customers, or obviously also non-Citrix customers as a new product.
All right. Great. We have another question. Does ITM add latency to communication traffic?
All right. So depends on, say, what means latency, but the idea is obviously to don't not impact the actual end users when we want to make a selection. So basically, if we talk about the DNS load balancing, the time to go to reach DNS servers is really in a matter of milliseconds. So that's basically nothing compared to the potential improvement that we're going to have in the actual latency to reach a closed data center or a faster cloud region. So the impact is really minimal. And besides, if we are using on our platform both the DNS load balancing plus the DNS authoritative services, which means to recall the zone and all the host configuration on our own platform, it's going to be the same server that do the static DNS record management and the load balancing. So in that case, that would even be much quicker, because that would be the same DNS server making the DNS resolution. On the HTTP side, which is mostly for the video use case, it's also that quick, and it's even easier to consider, because when you make this HTTP call, basically you can also implement some rules like, okay, if I don't get an answer in less than 50 milliseconds, I can decide to not take that into account, so that I don't impact the actual end users in that case. But yeah, so the short answer is that the impact is very minor, and versus the gain that we can have in terms of performance.
Okay. Great. That seems to be it for the questions so far. If you do have a question for Arnaud, please go ahead and use that control panel. Go ahead and put your question in, and we'll get to it. While we're waiting to see if we get any more questions, I do want to remind the audience that today's event is being recorded. So if you miss any or all of the event, you will be able to view the webinar on demand. Post-event, everybody who registered for the webinar will be receiving a link by email that they can access the webinar on demand. As well, the webinar will be on the Devops.com website, which also has a ton of other really great webinars that are available to access on demand or to sign up for coming up. So please, hopefully there'll be one or two there that pique your interest while you're on the site. Arnaud Beckhart, thank you very much. Doesn't look like we're going to get any more questions in, so I want to go ahead and give everybody 15 or 16 or 17 minutes back. But thank you so much for your presentation. It was very informative, and I'm sure the audience got as much out of it as I did. So thank you very much for your time. Would also like to thank the audience for joining us today. But for now, this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thank you. Have a nice day. Bye-bye.
Thank you.